On to section 7 now of chapter 5, the sum or difference of perfect cubes. And then we'll also solve equations. Now, what is the sum or difference of perfect cubes? Well, if you were to multiply a plus b times this, or a minus b times this, you would get all of this and then end up with a cubed plus b cubed. All of these things cancel out inside. So you have here what is called the sum of perfect cubes. And this one is the difference of perfect cubes. So much of this is the same. It's just a little difference of positioning of the signs. Now notice in this one there's only one negative sign, and in this one there's only one negative sign. So is there like a little recipe that we might use to actually factor this? And the answer is yes, and this is what I'm going to show you. And I'll do it, in a sense, my way, which is very similar to what the book is going to do too. Now, suppose you have a cubed plus b cubed. And the same here, a cubed minus b cubed. Here they're using capital letters. It's the same. I like lowercase letters. All right, now what's the beginning of the recipe? Well, first you want to recognize that it is the sum of perfect cubes, or the difference of perfect cubes. Then the recipe is very, very similar. You then put a set of parentheses for two terms and a set of parentheses for three terms. And that's the same for both of these. Now, whatever sign is there, you put here. Whatever sign is there, you put there. Now, the middle sign on your other terms, the three-term parenthesis, is going to be the opposite sign of that. So you can put that right there. Opposite sign of that. So this is what you need to sort of memorize, and you can have it written down in your notes. So now what you do is you take the cube root of that, which will be a, the cube root of that, which is going to be b. And that's the same down here. In fact, this result is going to be the same as this result, except for these signs. Now, the next stage is you look here and you square this term. Square that term. Now, you multiply these two terms together, disregarding the sign, because you already have the sign. That's going to be AB. And now you square this term. And there you have it. And that's what they have here. Okay? Now, there are some numbers that if you cube them, by the way, this is what they look like. So it's sort of like a little help that we had in the earlier section where they're saying it's good to know some of these perfect cubes here. Okay, so the cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5, cube root of 216 is 6. And then these are some smaller ones here. Okay? So in example 1, and we won't let you look at it, I'll just do it here for you. We have x to the third plus 27. Now, is this a perfect cube? Yes. Is 27 a perfect cube? Yes. So the recipe, parentheses for 2 terms, parentheses for 3 terms. This sign goes there, opposite sign there. Now you don't change or worry about the signs. Cube root of x to the third is x. Cube root of 27 is 3. Square this first term. Multiply these 2 terms together. Again, disregarding the sign because the sign is already there. 3x. And this will always be a positive because you're squaring this term. And there is the factorization of the sum or difference of perfect cubes. Again, you'll have to write the recipe out as you move on it to master it. And they're showing you what I just did then. All right, so let's do some of these. And we'll do A, and I guess there's room right down here. So are these the difference of perfect cubes? Yes. So a parenthesis for 2, parenthesis for 3. This sign goes there, opposite sign there. Square root of this, cube root of that is 5x. Cube root of that is y. Square this term. Multiply these 2 together, disregarding the sign. Square the last term. And that is the answer to letter A. Now let's do B right up here. And this way we don't get to see the answer. Cube root of that, this is a little tricky. Just divide that by 3. That's going to be, let me put the signs in first, plus and minus. So this is going to be m squared. Cube root of that is 4. Square this, m to the 4th. Multiply this. Square the last term. Okay. Now, number or letter C is a little tricky because this is not a perfect square, but I see I have a common factor of 2y that I can take out of each term. Then I get the difference of perfect cubes. So a parenthesis for 2, parenthesis for 3. My sign negative goes there. Positive goes there. Cube root of this is 4 y to the second minus 5 x to the second. Okay, square this term, I get 16 y to the fourth. Multiply these two together, I get 20 x squared y squared. You could reverse those if you want, no big deal. And then plus 25 x to the fourth. Now I may be going a little quickly. Again, you want to learn the recipe as best you can. And then for letter D, again, these are the difference of perfect squares, parenthesis for 2 terms, parenthesis for 3 terms. The negative sign goes there, opposite sign there. Cube root of this is r to the second, s to the second. Square this, r to the fourth. Multiply these together, r squared, s squared. Square this one, plus s to the fourth. Okay. Now, in a sense, this will be your practice. If this is good for your practice, you can go directly to the QuizMe. But if you want to try some, and again, hopefully you're writing these down, these are your models. We will be using factoring the difference of perfect and the sum of perfect cubes in chapter 6. So these are skills you will need to know, and you get to know them by practicing. And it's nice that we've done all of these. Here you had to take out that common 2y out of each of these, and they really are spreading it out, so I cut down some of the work here. Now, again, they're giving us a little review. The sum of cubes, the difference of cubes, and the difference of squares. Remember, these are called conjugates here. These don't have special names as far as I know. Okay, now we have an equation. So let's see what they want us to do, because we had factored this already. We're going to transpose that to the other side, equal it to 0. We factor it into this, factor each, or take each of our factors and equal it to 0. Now, for this one, we can get a 3. So we know that one of the factors will be, or one of the answers when we're looking for zeros is a 3. But this is not factorable, so we cannot factor that. So we have one solution. Now in chapter 8, we will be able to solve this, but we can't solve it by factoring. We're going to have to use either what we call completing the square or the quadratic formula. That's in chapter 8. So if we get this far, that is as far as we're going to go. Okay, well, again, there are items, even in your textbook if you wanted to practice. And I have a booklet too, that additional exercises where we've worked out lots of these. And hopefully you're going to get enough practice so you get mastery. Remember, you're shooting for mastery points. Just to show you from my other video, I have gained already some other mastery. I'm working on this myself as another little thing that I do. Okay, just 15 minutes. That was good.